In this video, I'm going to give an introduction to the natural exponential function. In the next video, we'll do an example where we're actually graphing it. We'll graph, a basic exponential function in this video, but we'll do an example where we have to graph it using transformations in the next video. Okay, so first off, what is the natural exponential function? So it's a function that takes this form: f of x equals e to the x. Okay, so you might have seen this e in other math classes. When you bring it to the power x, it's referred to as natural exponential function. It's such an important function that sometimes it's actually referred to as the exponential function, right? As if it's the only one, right? It's like so important that it's referred to sometimes as the exponential function. It's just an exponential function with a base of e, right? Up until this point, we've had exponential functions with different numbers, like, 2 or 2 to the x, right? And those are also exponential functions. So, but like I said, sometimes this is referred to as the exponential function. All right, so, before I graph this, what is e? Okay, so like I said, you probably have come across e in other classes. Maybe someone's told you it's like 2.718, blah, 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 right? And it continues just like pi, like it continues on forever. So what is e? E is, just to give you guys an idea, it's n as n equal, this is a summation, as from n equal to 0 to infinity of 1 over n factorial, which is just a fancy way of saying it's like this series: 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 2, 1 times 2 times 3 plus 1 over 2 times 1 times 2 times 3 times 4. Okay, so like you guys are seeing the pattern, right? So, etc. forever. We just continue with this pattern. All right. Also, you can plug this into your calculator and start summing it up and just keep on going, and eventually you'll get, the number, which is 2.718, etc. Another way that this is written, this is the same thing as the limit as x approaches infinity of 1 plus 1 over x to the power x. So in other words, if you were to plug in a really big number for x into this here, like a really big number, what you would get is, again, you can try this out with your calculator, 2.718. Alright, so like a really big number, I'm talking, hundreds of thousands, right? Just plug that in for x. You'll get approximately this. Alright, so that's what e is. So let's just talk about a little bit about what its graph looks like. So to do this, I'm just gonna plug in a few points to my calculator. So I'll plug in -2, -1, 0, 1, and 2. Okay, when you plug in -2, you get 0.14 approximately. You can go ahead and use your calculator. You can check this. 0.37, 1, 2.72, and 7.39. Okay, so if you were to graph this, it goes through at 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Here's 1, 2, 1, 2. Okay, so at -2, it's some really small number. At -1, so it's a really small number. At 0, it's 1. At 1, it's 2 point something. So that'd be like right about there. At 2, it's 7 point something. So that's above 7. Okay, so this is the way the function looks. Right? So it has the horizontal asymptote at y equal to 0. All right, so we'll do another graph of an exponential function using transformations in the next video.